Good evening, everybody. Whoops. Let me get some, making sure all my sound stuff is right. How's everyone doing tonight? Welcome to another episode of Mastermind Academy. Tonight, we're going to hop into some cool Python stuff. Just get my computer set up. I'm a little late. I was a little late getting, everything set up. My little pre-show set up and recording and making sure everything is good. But how's everyone doing tonight? I'm doing great. Did anyone who had the day off, how did you enjoy your day off? What'd you do with your time? I spent my day trying to edit some videos, render out some videos, and I ran into hardware issues all day. Well, it took me all day to realize that they were hardware issues. I'm probably gonna have to swap this graphics card out for something else because it does not play nicely with my computer. It took me all day to figure out that that was the problem. But I was able to render my stuff out just like I needed. Who's in? Roll call. Who's on tonight? I love to see your names. It makes me feel like my friends are on. What time is it? 8:01. We'll give people a few minutes to get in. Probably start right around 8:10. Hey, Jacqueline. Welcome from Minneapolis. I've been to Minneapolis. I came out to Minneapolis for a Blacks and Technologies conference. So I've been to Twin Cities twice, actually. So really nice city. So welcome. Yo, hey, Nameless Thug, Zero. Welcome. As you guys can see, I switched up my theming a little bit just for fun. Nothing crazy. I'm still, that video is coming out still on Thursday of how to get set up and like how to set all your stuff up like this and get from the stock GNOME 3 setup to this. But that'll drop Thursday. So if you're interested in any of that, that'll be coming soon. Let me I need to automate some of this stuff. Sending a few things. If you're in the Google Classroom, you should have got the link to the slides already. But let me send out this tweet that I'm supposed to send out. I'm definitely gonna change. I'm actually gonna switch up my entire setup. Hey DZE64, welcome to the channel. Thank you for the follow. Welcome. We're gonna get started in a second. Actually, I'll pull up this for a second and leave the curriculum up for a little bit. So tonight's data structures night. So this is stuff that we'll be doing tonight. Take a look. Data structures is nowhere near as complicated as it sounds when you first say the word. Let me send off this message. Let's see, cover Python. Man, I can't type still. Data structures. Man, yeah, today was a good day. It was nice to be off of my day job. It was nice to be off from Fearless for a day to just kind of get some stuff together that I've been working on for this. Like I said, I did run into some computer hardware issues, which was super annoying. I haven't had to troubleshoot like weird issues like that in a really long time. So that was really weird. But besides that, pretty good day. Got to work out, got to relax a little bit. Wasn't under the gun for anything. So yeah, twitch.tv/mastermind.io. Let's give it some hashtags. Hashtag Python. Should move this down. That's easier. But then I keep hitting it. Python, hashtag bootcamp. Hashtag coding. All right, let's send this off. All right. Yeah, I'm sorry everyone doesn't get the day off. We do federal government contracting, so we do get the day off today, which is nice, which is definitely nice. You know, I do take time to remember what today is for. You know, I've benefited a lot from what MLK has did. So I do recognize that, but it is nice to have a day And especially in January after all the holidays, you're looking for a little break. It's definitely nice to have some time to kind of get yourself together. I saw you reference Udemy, one website maybe. Any courses you recommend for what are you trying to learn? I love Udemy courses. Udemy, yeah, I think Udemy is great. I like that you can purchase your course and that you own it forever, so you can get to it whenever you want. The Python Bible is pretty cool. If you're trying to pick up some more Python stuff, it'll cover basically the same stuff that we cover here. But I think it's a good course that doesn't go crazy and trying to get too deep into the nitty gritty. It gives you the tools of Python, kind of make sure you know those things, because after you know those things, you can go on to learn what you want. But that's a pretty good course. If you're trying to learn how to code, period, and you want some computer science concepts and you want to learn all that stuff and you want to really understand like deeply how like computer science topics, even if you don't want to learn Go, there's a Go course by a guy named like Todd McLeod. I think his name is Todd McLeod. And there's a Golang course. I would get that because it is a Go course, but it's really a computer science course. He actually teaches, I think, at the University of Michigan. Interesting guy. He does some stuff like in his garage. Sometimes you could tell he just like came from a party or something. He's got like a red cup and he's definitely drunk, but he keeps it moving. But that's a pretty good course that I learned a lot from. There's also a good Kubernetes course. When we get there, I'll share it. There's a good Kubernetes course, but there's a bunch of stuff on there. Yeah. Are we doing comprehensions or just the basics of arrays? We'll be doing some list comprehensions. We'll be doing all kinds of stuff tonight. Yes, we'll go over some list comprehensions. I think that you'll be introduced to them. We'll talk about them a little bit, but they'll make a little bit more sense once you kind of learn some other things. But yes, we will be doing that tonight. So we'll dip our toe in that end of it tonight. Man, I have something like, I don't know, I just ate, so we've got the Lacroix back on deck. Lemon and lime are here tonight to make sure we stay hydrated. So if anyone from Lacroix is out there, anyone who has connections to Lacroix, let them know that we're sharing their brand. Interestingly enough, the lemon and the lime Lacroix are not good together. It's not like Sprite. And I think it's because the lime is overwhelming. But we had to try, we had to experiment when we have access to many flavors of Lacroix. But it's best to drink them separately if you ever thought that that's something you wanted to do. You code up social media post script as part of the Python course. I absolutely could do that. But I could do that. I already have a tool called Buffer, which would allow me to kick the stuff off. But the problem is you've got to have the foresight to set this up beforehand. So there are ways to do it, but it would be pretty easy to write a Python script to post to Twitter's APIs or something. Maybe that'll be something fun to do towards the end. I don't think I told you guys what the projects are, so maybe I'll change the second project and do something like that. Helps for the DevOps peeps too, absolutely. The Modern Python 3 Bootcamp. I think I saw that recently. I think that one is relatively new, that Modern Python 3 Bootcamp. And I'm interested to see how you like that one, AutoExec. Let me know. Sorry for the typos in the new keyboard. Absolutely frequency hop. Like I'm a part of the new keyboard gang too. I'm struggling over here still, but we're getting good. Not only am I struggling with the new keyboard, I'm learning how to type faster, and so I'm breaking muscle memory. So I'm no longer I'm actually thinking every time I type, which slows me down substantially. But I am more accurate. I'm definitely getting more accurate as a touch typist. But yeah, I'm struggling over here. This one helped me get certified for Linux Academy. Let me check this one out. Is this the one? Okay, cool. Yeah. All the cloud stuff is probably pretty good. I just use A Cloud Guru for all that studying for cloud certs. I'm actually about to start a whole series in which I get I'm gonna start out with AWS, and I'm gonna get all the associates and both of the professional AWS certs. I'm gonna do a little thing on just kind of how you would approach that, how do you study for it, things like that. And then I might dive into some other cloud providers as well. I might hop into Azure next, as well as kind of chronicle my journey to the CKA, to the Certified Kubernetes Administrator, since that's the thing out of the most. I have a substantial amount of AWS experience, but I do not have a substantial amount of Kubernetes experience. So that one's going to be kind of fun, just because I'm coming from the same level as a lot of people on that one. for that one. All right. Let's see here. Oh, yes. Thank you, AutoExec. Do not buy, and Udemy is probably gonna get mad at me for this, but do not buy if the Udemy course is over $12. If it's over $11.99, do not purchase it. It will be on sale within the next week, guaranteed. They always say 1 day left of this sale, buy now. Then stuff does go back up to full price for like a day or two, and then it's going to be on sale again for another 3 days. So if the stuff is more than $12, don't buy it. Man, let's say $20. If it's not more than $20, don't buy it. Just give it some time. Everything will be $9.99. It'll be either be $9.99 or $11.99. So you can wait for those days and pick up all that you can pick up. Kafka course. I haven't messed with Kafka at all yet. But Docker with KDS, with Kubernetes. Cool. All right. So tonight we're going to be talking about data structures. Data structures are actually it's a simple concept. It does take a little bit of time when you're first starting out to get a handle on the differences between these. Luckily, there's a lot of similarities between these things: lists, dictionaries, arrays, sets, and tuples. For a number of reasons, actually, I may have pulled sets from the curriculum. Can't remember. Let's check the slides. Is this the right? This seems like the wrong, yes. This is the wrong, I'm logged in as the wrong person, the wrong Aaron. I have 3 different Aaron accounts, one for work, one personal, one for mastermind. And I think data structures. Cool, are we doing sets tonight? Lists, give me guys a preview. Okay, we have sets, that's fine. I thought I might have pulled those, but yes, I will talk a bit about arrays. We're definitely gonna talk about arrays, but we're not gonna dive, so there are some caveats to arrays. So if anyone was looking for a lot of array work, we will be diving into lists and other things. We will talk about arrays, but we won't do anything. We won't do a lot that specifically addresses some of the weird ways that Python uses arrays. Again, we'll touch on some of those things, but we won't go incredibly deep. And we'll talk about that in a little bit as well. All right, 8:13. Let's get started. So getting familiar with data structures. Without structure, there's only chaos. All right, what the heck is a data structure anyway? So this is one of those words that I think when I was going to school, I think when like there was classes called data structures, it sounds so complicated. It sounds like something that's like super in depth, that's gonna be really, really tough, but it's not really tough at all. A data structure is simply, it's a particular way of organizing data in a computer so that it can be used effectively. So this is the same thing for organizing anything. It's putting some structure, it's putting some organization behind this thing, which is the data, so that you can use it more effectively to solve your problems. So a very simple concept there. No magic here, no fancy schmancy stuff. Simply a way of organizing data so that it can be used effectively. And so we're gonna hit each of these. We're about to go over all those different data structures. We're gonna hit them. We'll run through we'll mess around in the interpreter or in some files with them. And we'll just mess around to get a good feel of what they are and get a good feel of what they do. The first data structure that we're gonna be talking about is a list. And so Python has, this is what people are generally thinking about when they come from another language and they first say arrays. There are arrays in Python, but this is generally what you're going to use. You're going to be using a list probably 99% of the time as opposed to an array. But a list, what is a list? A list is a data structure in Python that is mutable. So we're going to be using a lot of words like this. What does mutable mean? Mutable means that it can be changed. So think about like a variable, something that can be changed. So a list is mutable or changeable. It's an ordered sequence of elements. I should have probably bolded ordered. That's really important. So ordered means it has an order and that order matters. So it's a sequence of elements that's ordered. Each element or value that is inside of a list It's called an item. So everything inside of a list is called an item. Again, think about over on the left. Imagine this is not The Simpsons. Imagine this is a shopping list, grocery list. Everything on that list, your milk, your eggs, those would all be items. Lists are defined by having values between square brackets. So we talked about strings, having double quotes, and there's some, we talked about some other data types, but for lists, whenever you see square brackets, these square brackets, open one and a close one, think list. That's how you create a list. So lots of items here on this slide. Working with items in a list. So one, we just learned that a list is defined by this open and closed bracket. So let's take this and let's head over to, let's open up a terminal and let's hop into the interpreter for now. Let's go ahead and update. Nope, can't update, no problem. Wow. Python 3. All right, so let's go with, let's type something like our list. And this is what I had on here. And I'm gonna give it an open bracket and a closed bracket. So I'm making a variable. Let's talk about what I'm doing. I'm making a variable. I'm setting it equal to an empty list. So, whoops, let's go back up top. Just trying to get used to these keyboard shortcuts again. Defining an empty list. If you wanted to make it a list, you can make an empty list. Now, I'm going to give you some, I'm gonna throw out some things early for you. Again, it said the definition, it said that a list was mutable or changeable. So we can create an empty list and we can add things to it. So just because it's changeable, we can add things to it, we can delete things from it, and we can change the values inside. So you can define an empty list with nothing in it, and then you can add to that list later. So this is how we're gonna define the empty list. And let's take a look back down and let's check the type of our list, because this data structure is also, it's also a type. So our list, and we can see here that it spits out lists. It does not spit out array. So you may be thinking of arrays. Essentially, lists work for everyone who's coming from a different language and just trying to learn some Python. A list works essentially the same way an array does in most languages. Again, there are a few caveats, but 99% of the time you're going to be using a list. So you can type in type. You can get the type of the list item with the square brackets, and it says it's a list. So pretty simple there. So that's how you define an empty list. Now, how do you define a list with values? So you can create a list. You do not have to create an empty list and then add to it. We can change our list. We can set that equal to open bracket, and then we can add any number of items in here that we'd like. So it doesn't, unlike Go, if you're watching the Go stuff, because this isn't a statically typed language, I can put in whatever types in here I want. So I could have the number 2, and everything in a list is separated by a comma. So this is the first item in the list, and then I could do a comma, and then I could say the string 2 now. So I have a number, I have an integer. Now I have a string, and what I need to do to separate it, another comma, and let's throw in pi, because that is a float. So that's a different type. And then let's throw in something like false. I actually don't remember in Python if it's capital or lowercase, but we're gonna find out in a second. So that's a Boolean value. So we're gonna set this to be our list, and false is not defined, so it's probably a capital F. All right, awesome. So now we've defined our list. We can do the type again just to make sure it's still a list. Now that we've added things to it, let's print it out. Let's print out our list. Whoops, that spelled something different. Oh, I spelled it out list because I can't spell. But no problem. That's good, because now I can show you what an empty list looks like when you print it out. So if you print out an empty list, it is just the open bracket and the closed bracket, the same way that an empty string is the open quote and the closed quote right next to each other. Let's go ahead and print out list, the one that I created. See up here, I just spelled it wrong. Cool. So it prints out exactly what we have up here. Again, with 4 different data types. We have an integer, we have a string, we have a float, and we have a Boolean. So very simple. And I could have many more than this if I needed to, but this is what I have for now. And so that's how you define a list. That's how you declare and assign values to a list right up front. What else would you want to do with this? So now that I have values in the list, I got some values in the list now. This one has 112 eggs, 3.14 in my name. How would I reference an item that is in this list? Let's say I wanted to use this list in my code. Remember we talked about 0 indexing. So list, just like I think all of these data structures tonight will be 0 index. The ones that are indexable, the ones that are iterable, they're 0 index. So that means the first place, it means that each location, each item in this list has a location reference. It has an indexed reference, and it starts with a 0. So the 2 right here, the first item in the list, will be referred to with the 0 index. The second thing in the list will be referred to with the 1 index. So again, a 0 index, the first item starts at 0 rather than 1. I try to help people think about this like if it's super weird, but I've been to a couple like hotels where the ground floor is ground or like floor 0, and then the next floor up is actually floor 1. Super weird. Don't see it too often anymore, but it's kind of like that. Imagine that 0 is the ground floor, and the first floor, even though you're going up to what you're used to being the second floor, is the first floor, and so on. But this is in the 0 spot, 1, 2, and 3. So even though there are 4 items in here, you reference them starting from 0, 1, 2, and 3. So how do I reference an individual one? Let's say I wanted to reference pi. I wanted to pull this out of the list. I wanted to use this value. I would print out the name of you would first type the name of your variable. So the name of the variable is outlist, and maybe I should change that. But you just throw into some square brackets. The number that you want to see. So, or the index of the item that you want to see. So how many items are in here? 1, 2, 3, and 4. But we know it starts at 0. So if I want to reference pi, I would say not 0, not 1, but 2. So we're gonna look for 2. So this is a common paradigm, and maybe I'll type this up here. Let me say variable. How referencing an item and list variable, just in case you want to copy and paste it somewhere. Variable, and then in the parentheses is going to be the index, and then yeah, that's it. So that's what you're going to do right there to reference an item. So if I do this, it prints out only 3.14. So I reference the list, I use the list variable. So if I just printed out outlist, it would print out the entire list. But I put 2 inside of square brackets here. And so now it references the index associated with that. So again, a little more practice. Let's put a 0 in here. And if we put in a 0, what do you think it's going to spit out? Remember, I said everything is, these are 0 indexed. So 0 is the first spot. So it should print out the integer 2 because 2 is in the first spot. And you can see here that it prints out 2. So not crazy tough. The syntax of remembering how you call it might be a little bit tough. This might be a little confusing, but again, you can look up this at any time. What you need to know is that lists they are 0 indexed. They are ordered, so the order will always be the same, and the order does matter. So you can reference things by their location, and again, you can do so using that index, the number of the index. All right, back up top. Let's see. That's not what I wanted. I wanted this one. There we go. Okay, so we defined an empty list. We defined a list with some values in it. We referenced an item in this list, But how will we change an item in the list? We said that lists are mutable. They're changeable. They can be changed. I would write down, if you're taking notes, I would write down the word mutable. It's a good word, especially if you're doing some DevOps stuff. Mutability and immutability, actually in programming as well, is a big thing. It's an important topic, and it will come up again in this data structures session right now. But again, mutability, if something is mutable, mutability means it can change. And how would we change an item in the list? So you can change an item in the list by using it like a variable reference, the same way that you would change the value of a variable. We've learned how to do that. You know variables can change. You set a variable and you have it equal to something. So my name is equal to Aaron. And then later on, I can just reassign the value of that variable. So now I can say my name is now equal to Thomas. So you can do that. But let's change one of the items in the list. So take a look at this. We're referencing which item we want. So we're calling the list and we're calling the index item that we want to change. So there's a 1 here. So what is 1 going to reference? 1 is going to reference not the first spot, but the second spot, because the first spot again is 0. I'm going to keep plugging that in. First spot 0, second spot is 1. So it's going to change 12 to the string 10. So let's go ahead and try to change something in the example that we have. So let's print our list. So we know what's in it. All right, so we know what's in our list. Let's go ahead and change 3.14. Let's change it to the word pi. So we know it's pi. Let's go ahead and let's change it to pi. So let's print. Actually, so we don't even do that. We need to do outlist. And then we need to select the index that we want to change. So 0, 1, 2. So we're going to change the second index and we're going to change that to the string of pi. And so again, this is just like changing a variable and we're just telling what place to change. And we hit enter and let's go ahead and reprint our list. And now you can see 3.14 is no longer in the list. There are no more floats in here. There's just pi. And so now everyone knows it's pi, but we were able to change that item. And again, you can do this as many times as you want. You could change any item that's in this list. Now, let's check one other thing. What would happen if we tried to change, let's say we were trying to reference false. And let's say we forgot that these things were 0 indexed. And let's say we were trying to change false to true. And we were going through and whoops, that is not what I meant to do. I meant to go backwards. And so now pi is no longer pi, it is true. But let's say we were trying to change the last thing to true, but we forgot a 0 index. So we said 1, 2, 3, 4. I want to change the 4th item to true. So let's put a 4 in here and let's see what happens when we do this. You hit enter and you get an error. You get this trace back. It's very intimidating. No big deal. It lets us know where it happened at. Index error. So we learned about 0 indexes. So the word index, this should be jogging your memory a little bit, even if you forgot. List assignment index out of range. That means that the range of numbers, we're going to learn about range in Python, which will come later, but the range of numbers that you have available to you in your index, the number that you selected is out of range. And that's because there's no 4th index item, because there are only 4 items in here, which means the highest index would be 3. So you have to make sure that your indexes are right. Off by 1 errors are often a problem in programming. But yeah, so if you ever see something like this, this means you're probably off by 1, most likely. If you're confident you're doing something right, you're probably simply just off by 1. So you got to make sure that index is a valid index. I see in here someone says, what about a negative index? So you can, let's do print. And let's do, whoops. Let's change this to -1. What do you think, before I hit this, what do you think is gonna happen here? You might have tried it because people put it in here. And I like the I like the slices there. We're gonna go over some slicing in a little bit, but what do you guys think is gonna happen if you do -1? Is it gonna give us an index out of range because there's no -1? Yeah, what do you think it's gonna do? Need a little water. And let's find out. So print out list -1. So let's take a look. It says false. Now this is interesting. This will probably confuse you. I probably should use different values, but let's print out what out list is. It's 2, 2, true, false. So false is in the list. It's not giving us, it's not returning to us a random Boolean value, but yes, the negative number will now go backwards. So -1 now flips to the other end of the list. Let's try -2. And now it says true, which again, it's kind of weird. It kind of seems like that's the output of whatever we're running, which it is. But so now -2 goes back this way. So -3, -4. Let's go -5. I actually don't know if this works. Let's try -5 so that it loops around again. And so it can't go around twice. That's something I learned here today. But it can't go around twice. It looks like it can only go around a single time. Yes, so it can only go backwards through the list one time, which is good. I'm glad it can only go through once because that would confuse me a lot. Yeah, that would confuse me a lot. So yes, negative will go from the other end and work backwards. All right, so that was assigning. So you also could do, if I wanted to change the last item in the list or the first item in the list, I could still do it like this. And I could still do like out list of -4, which is 2. We could change that to 3. And if we print out list, now you can see that first item is 3. So you could use either one of those if you want. Don't use a negative number if you don't have to. There are situations that call for the negative number where it makes sense, but we're not gonna do that. And we're gonna go over those slices in a second, you see goodness, in a little bit. As far as I know, it's Python specific. I do think that slicing isn't Python specific, but I think negative slicing also isn't Python specific, but I love it. Hey Shanda, sorry, I got some visitors over here, but yeah, you can do like negative slicing in like in Go, but I don't think you can do negative index values. I don't know. It's something I would have to mess around with. Again, it does get really difficult to remember what has what and what does what. Homework assignment: create a program that returns if a given input is a palindrome. That's a good one. That is actually one of the examples that is on exorcism. So we will definitely be going through one of those. We're not ready for that yet. We have not learned enough yet to be able to do, well, yes, we have, in the easiest way possible. But I think there's some levels to that. But I don't think we're ready for that. I think we need to solve some problems together first. Bonus points if you do it recursively. For loops all day. Cool. All right. What else do we have left for list? So there's like 10 things for list. Let's go back up. All right, so we changed an item on the list. So empty list, just think about those brackets. Define a list, so brackets with items in between. Item can be kind of really any data type with a comma separating them. So every time you say comma, that's a new item. Referencing an item on the list, we can give the variable name of the list, the variable name of the list with the index value inside of square brackets, and then changing an item on the list. We can do that like a variable. We can reference that item and then change the value, set it equal to a new value, assign it to a new value. Now, what if we wanted to add items to the list? We have a few items on this list. What if we needed to add one? And so now we're going to get into this is a method called append, and let's practice using that. So append, the word append, I'm not sure what the definition is, but I'm pretty sure the definition is something like adding to the end of something. We'll see what the official definition of append is. Append definition. to add something as an attachment or supplement that's being in the rear or in the back of it. So appending will add that. So remember the word append. If the word append is not something that you were used to, add it to your repertoire, add it to your vernacular or your vocabulary. So let's go ahead and let's append an item. All right. So now we're going to change the name of we're going to make our list. I think this works. Our list is equal to out list because I'm tired of typing out list and remembering to type in out list. And we're going to print we're going to print our list. All right. So that's cool. So let's clear this if I can. Can you clear? There we go. Yes. So printing our list, this is the list that we have. Let's say we want to add a new value. Let's say, whoops, we made a mistake. We replaced pi with true. What if we want to add pi back to this list? We don't want to change any of the values. We want to add a brand new item. So we want to basically add in a comma and we want to add a new item after that. We have to use append for that. So append is a method. So what you have to do is call it with a dot. So we're going to type in our list. So we're going to reference the variable that we're using. So right now we're using our list, and then we're going to do dot append. And append is a function. And so remember, I think we talked about functions a little bit just so that you were new to use the parentheses. But we'll learn about functions, I think, in another class or two. Actually, I think 3 classes from now. But we're going to say our list dot append and the item that we want to append. So we want to append the word pi. We want to add pi back to this. So again, don't sweat the syntax. Don't be bothered if you don't remember the syntax, or like me doing this dot append thing. You're like, oh, what's going on here? This is different from anything that we've done. Cool. Write it down right now. Just know you can add things to a list, and that's using this append function. And so you append, and whatever you want to append goes inside of the parentheses. And do I have 2 parentheses here? Yes, I do. Let's see. Okay, so our list dot append pi. So nothing comes out of that. Nothing comes out of that. You don't need to set this equal to anything. But now let's go ahead and let's print our list again. And now we've got pi on here. We've got the string pi added on here. Great. So we can do that, and we can go ahead and append any amount of things that we want. I don't want to say any amount, but yes, anything that we want. Append Aaron and print it out again. And now Aaron is on there. So we can just keep adding things to this list. Again, think about already, you should kind of be thinking about, like I said, shopping list before, but just imagine like if you've never written a program before, start imagining like now you're starting to get some tools that you could use to actually create a shopping list. Like, you know about strings, and you know how to get user input, and you know how to make sure those things are strings, and you know how to create a list now that you could use to save this data, and you've now learned how to push things into that list or append things to that list. So we're on our way to be able to make a very simple, shopping list application. We're not going to make one right now. Maybe if we have time at the end, we'll just make a quick one. Because you can make one. It won't be very good. I would say make one using the things that we've learned so far. I don't want to hit you with a bunch of stuff you haven't seen yet. But we could make a shopping list application off of the things that we learned, where it asks the user for input and we add it to the list. All right. So using the append function, we can add things to our list. Okay. Deleting an item from a list. So we know how to define one. We know how to make one with values. We know how to reference an item in a list. We know how to change an item in a list. We know how to add an item to the list now. The last thing that we would need to do is to delete an item from a list. So this might be a little confusing. There are multiple options to delete items from a list. There's also one to delete everything that's in a list. I think that's clear or something like that, like .clear, but we can use one of these two. So look at this append, and it's actually, even though we don't have anything inside of the parentheses, the syntax is actually very similar between the append, the add, and the delete. The only difference is if we want to delete an item, we have to specify which item we want to delete, right? Well, usually, yes, you're probably going to want to specify the item you want to delete. You can just delete like the last item. But yeah, so you can use two different things. There's remove and there's pop. I think the only difference between them is I think pop removes and also returns the value so that you can save it to something else. But we'll check that out in a bit. I actually don't. It's been a while. Don't remember the two. So let's mess around with the removal. Let's remove some items using the either .pop method or the .remove method. We'll use both. Let's go back down, and let's say we have true and false in here, and we know we didn't mean to put true in here. So let's go ahead and remove that. Let's pop it first. Well, yeah, let's pop first. Let's do, what do we call this? Our list. And now we have to tell it which item we're going to be wanting to pop off of the list. So true is the third item on the list, 1, 2, 3, but we know it's 0 index, so 0, 1, 2. So we want the second item. That's the item that we want to get rid of the list, and we're gonna do .pop. And we don't have to put anything in between here, and we can just run this. All right, type bool has no attribute pop. So let's take a look at, whoops, what did I put in here? That's interesting. Let's try .remove. I think I know why it's doing that. I'm just, am I typing something? Isn't our list a, oh, I'm sorry. I added that was dumb. Yes. I'm sorry. I knew what I was doing, but it's a list method, .pop. So you do put it in here instead. I don't know why I did that. So which number did we say? We said 2. Our list.pop. I'm gonna change that right now before I forget. I don't know when I must have been tired when I made this. Let's go back. I don't know why I did this at all. Let's put something like this. And remove is the same way. Yeah, so you do need something in the parentheses. So I told it you still need to pass in the index, and the index will pop it off. Actually, can you remove or pop the value? I think pop needs an index, but I think remove will take the value. So let's try that real quick. Let's look at our list. So we can see here now that true is removed, but I see 2 right here. Let me see if, I don't think pop will take 2. So if we do 2, I don't think it can take a value, and it doesn't, but I do think remove does. So we change this and we type in remove. Remove will remove the item from the list. And so now it chooses. So remove you can specify either the index. I think can you do the index? I don't even know. That's for remove. Let's see. Let me just confirm. All right, cool. Yeah, you should be able to do either. So for remove, you can use either the index or the value to remove something from a list. But for pop, pop needs the index to remove it. And I also think that pop it pops it off. Actually, you can see here when we did remove right here, it didn't spit out any output underneath. But when we did, this is hard to see, but where do we do the pop at? When we did pop, let me do pop down. If we do a pop for, we do a pop for 0, it removes it, but it also returns the value. Remove does not return the value. Pop returns the value. So this means pop is used a lot because usually, not usually, but sometimes when you're removing things from the list, you want to retrieve that information and you want to save it to something. So pop allows you to do that. So I could, let's take a look at our list again. There's only 2 items on here now, but I could also say like deleted item. I could set a variable called deleted item equals our list dot pop and 0. And so that's going to pop pi off of the list, but it's also going to return the output so that I can set it equal to something else. And then if I do print deleted item, it's equal to pi. So again, pop has some extra features there for you to be able to do some things like that. That was interesting. Cool. All right. So that is a list. Let's take a break. Take a quick break. We're good on time. It's only 8:45. Take a break. Take it in. A list. Very simple. It's just like a shopping list. Think about square brackets. You add things to it, and you can keep adding things to it, and it's separated by a comma, and you can add different types to it. So you don't have to add only strings or only integers. You can add a bunch of things to it. You can reference the items in there. So if you want to get down to where you said, I want eggs, you can find eggs on there and you can grab it via the index. It's an ordered list. So the order of this list does not change. The order is important. And because of that, it's 0 index. It's indexable, it's iterable. And you can use that index number to refer to the item that you want out of that list. It's mutable. Things in it can change, so you can change the value of items in the list. You can add new things to the list using the append method, and you can remove things from the list using pop or remove depending on your use case. So any questions about that? Know where stuff blends together? Yeah, for sure. Parameters by default means pop removes the last element. Yes, so if you do not, you can actually use pop without anything. So let's append. Is there more? Append pi, and that's on our list. And let's print our list. So ignore what I just did. You're gonna learn that stuff if you're watching the Linux course. I just used some fancy Linux commands to recall some of the commands that I already ran. But now we have this list, and it has Aaron pi. Now this is actually, this is perfect. This is perfect to show you the remove and pop. Actually, let's add on one more thing to this. Let's add on like the number 2. All right, so we said we could use remove to remove a value. And you can see here, I have 2 of the same values on here. So what happens if I do that? What happens if I use remove and I pass an Aaron to this list? So let's do our list dot remove and go ahead and pass in Aaron as a thing that we want to remove from the list. And let's take a look at the list. And it removes one of the instances of Aaron. I'm actually not sure if it's the first one or the second one, but it will only it does not remove both of them. I think it removes the first match that it gets to. So it's probably the first one, but you can do it twice. Yeah, so it is the first one. Length got shorter, last index changed unless you went backwards. Oh, okay, hold on, I'll get to that in a second. So now you see how remove works when there's 2 of the same items in the list. And now that we have 2 items in here, if you use pop and you do not pass in anything, by default, it removes the last item. So basically this is like the same thing as doing like -1 in here. So it goes to the last item in the list, or the same thing as doing, we'll learn about length a little bit and we'll talk about length in a second. Again, just as a refresher, or it would be something like the length of this list, of our list. What is it? -1, I believe. List -1. But more think about -1. But you can see here, if I just do this, you can see it pops off the last item. It returns the value to us. And if we print our list, it is pi. So we're good to go there. What else? Let me see. Hey, can anybody tell me why I can't remove the last index twice? Great. That is a great question. Looks like people have already kind of answered that for you. You can if you use -1, but okay, length is a perfect time for length. So let's go ahead and append some options to here again. Append, CR. Man, I'm hitting all the wrong. C. Then caps lock is on. No, it's not. Append. Let's append pi. Append Aaron. We've got a couple things in here. We got pi in there twice. Let's do 4. All right. So now if we look at our list, we know that we can look at this and count this up. 1, 2, 3, 4, 5 items. We talked about length before, but there's a length function. So if I wanted to find out how long this list was or how many items were in this list, I could use this length, len basically, and pass in the thing that we want to know how long it is. Remember, we did this with strings. And so we can use len and then put our list in the parentheses, and it will count up how many items are in here. So for your question, Anansi, basically what happened is when you pop something off, when you deleted something off the end. So if you did rlist.pop, .pop, and you did something like 4, like to do the last element. So you went like 4 so that you can get the last element off of this list. And you press this, whoops, I didn't mean to, oh, it popped off 4 because that's the same number. But if we print out our list, it's gone. But if you do the length of your list again, now the length's only 4 because now there are less items in here. So if you were using the actual number instead of -1, you can't pop that off twice because now the length has changed. And it looks like frequency hop will let you know, give a good instructions for that. When I run my code to remove the function, I get the following built-in method: remove of list object at. So that is, I think that's because, that might be because of the type that you tried to remove. That's the return of pop. If you're doing pop, maybe, yeah, what exactly are you running? For some reason you're getting the method object instead of calling the function. Age equals 25, 25, 2050, age.remove. Print. Oh, okay. Gotcha. Yeah, you see, goodness, they got you covered there. Got you covered. Perfect. All right. So we spent a lot of time on lists, which is good because lists are very important. You're going to be using lists a lot. And again, like I said, if you're coming from another language, you're going to be using lists in the same way that you would be using arrays. Again, arrays are a thing in Python, but you generally, people generally use the list because you have to explicitly define an array rather than a list. So that's one of the main reasons, but there are a few others. All right, let's move on down to something new. Dictionaries. Dictionaries are very fun. I'm not sure why this was supposed to be a magnifying glass. Let's see. I don't know why the emoji did not work here, but it's supposed to be a magnifying glass here. Oh no, it's supposed to be a key. It's supposed to be a key and not a magnifying glass. And actually, I think that key is very important. So we're gonna get that key into place right now because I think it matters. And I want you guys to have it if you have the link to this. What do I do? Where's the special characters? Special characters, symbol, emoji, key. Wait, did I change it to emoji? What? Insert. Special characters. Emoji. That seems right. Can I just type in key? Interesting. It's not showing up for some reason when I just did this the other day. All right, no biggie. This is supposed to be a key right here. So I'm just gonna type in key because it's important that you know key plus value store. Dictionaries, KeyValue Store, real dictionaries in real life. The dictionary, the book that you open up is a KeyValue Store. So what's the key? The key is The key is the word that you're looking up. So if I'm looking up the word append, like we just looked up append, we know the key that we want to see, and we open up the dictionary and we look around and we know it's in alphabetical order, and we scroll down and we find the key append. And then that key append has a value. The value is the definition. So read the word append, we look to the right, it's got the value, and those two things are connected. Dictionaries in Python, same thing. Key value store. You set a key, you set a value for that key. Dictionaries in Python is an unordered collection of data values. So the last thing that we did, lists, were ordered. They could be referred to by their index. The order mattered, the order stayed the same. Dictionaries are an unordered collection of data values. Very important to know that dictionaries are an unordered collection of data values. And they're used to store data values like a map being an item or a value that's mapped or connected to another value. Dictionary holds key, value. So key value stores are very important in programming languages. You'll see them a lot. The hash tables, we're not doing hash tables, but yes, them hash tables, but dictionaries are great. So this is a way, remember, data structures. This is a way to structure your data. This key value store is a way to structure your data so that you can use it more effectively. So let's learn how we can manage and kind of use this data coming from a dictionary. All right, we learned how to define an empty list. What was an empty list? An empty list was an open square bracket, closed square bracket. Now, dictionaries. Dictionaries are an open curly brace, closed curly brace. If you guys call these things something different, squiggly, whatever, that's what they are. So a dictionary is a hash table, but the concept of hash tables and understanding how hash tables work is a whole different thing entirely. And I don't think it's valuable right now to know about. But we can definitely talk about some of those things. But yeah, dictionaries, they're hash tables with some extra bits. Yep. All right, so open closed curly braces here. So that's how you define an empty one. Let's take a look and let's do that. So let's clear and let's do, I'm just gonna do dictionary, short for dictionary. Dictionary equals open curly, close curly. And we can do the same thing we did before with type. And we can type this and it lets us know that it's a dictionary. Maybe I'll change the name of it just because that is the type and it may be a little confusing. I want to be something, I'm just gonna call it X because I don't want to type a whole lot. So let's do X. Let's use X now. X equals open close. And we will do, let's do type X. All right, so X is a dictionary, empty dictionary. Now, how do we define it with values? Same thing that we did. We're gonna go through the same functionality that we did with the list. So how do we define it with values? This is a little more complicated now because now we have, what's happening? Oh, there we go. Now we have these key value stores. So it's a little more confusing. So our dictionary, we can see here equals the key. So the key is name. The key I have here is name. There's a colon and then the value. So again, I said that these are key value stores, and they're separated. They are separated by colon. That's important to know that a colon separates the key from the value. That's how you know you're moving from the key to the value. And each of those items, just like in a list, is separated by a comma. So we have name here, and the key is name. The value is Aaron. Then we have a comma here. Then we have age. We have the key of age and the value of 21. So it looks like we only have 2 dictionary items in here, 2 key value stores in here. So let's go ahead and do exactly this with our dictionary. So X now equals, actually this might not work. Can you use that with SQL or why would you? Yeah. They're unordered, but nearly instantly accessible any values as long as you want. Yep. So let's go. The key is going to be name. And we're going to separate it. Again, once you have the key that you want, you're going to separate the value with a colon. This is the first thing. Then we're going to do age here, and we're going to set my age equal to my real age. All right. So we set that. We hit enter. We only have 2 items here. So dictionaries are also mutable. So they're not immutable. They can be changed. You can add things to them. You can change values in them. And so let's go ahead and let's print out X and just see what it looks like when you print out a dictionary. So pretty simple, looks similar to a list with the comma separating the items, but now each item in here, each item per se, it has 2 things. It has a key and it has a value. All right. So this should be an easy this should be a fairly straightforward concept, high level coming from lists. But again, the key and the value is the thing that we're adding to this. And again, think dictionary, this is exactly how a dictionary works. You look up the key so that you can get the value. This is the same thing. Now, how do you reference an item in a dictionary? You can reference an item in a dictionary by its key. The key is the thing that is important. Yeah, the key is the thing that's important. Well, I mean, everything in there is important, but you can reference it by the key. So we know that we have a key called age. So if we want to reference something, we can do print X, and the key that we want to see is age. And I want to know exactly, I'm looking up this dictionary item for age. And when we print that, we get the value. It gives us the value. So if we print the key, if we print the variable name with the key, it gives us the value. It returns the value. So if we change this to name, it prints out the value for name. Now, why is this different from a list? Like, why can we not use the index number like we did before? Let's try it out. Let's see what happens. Maybe we can. Maybe I'm just messing with you. Let's try. We know there are 2 items in this list, so let's try to hit the second item in the list. And when we run it, we get a 1. It says key error 1 because it's looking for a key. But the reason why dictionaries you can't use the index item is because they are unordered. So the order changes. So those key values, they can kind of come out any different way. They're unordered. It's not iterable in this way. It should always be fine when you print it. I always wondered about that. But it's always, yes, it's unordered. So there's no index value for each of them because it's unordered. Things will not be in the same place. It's not indexable. It's not iterable in that fashion. So you have to call it by the key to get the value. So great. Instead of the index for dictionaries, we have to use the key name. So the key being the first item, KeyValue Store, KeyValue Store, KeyValue Store. So key is the first thing, and that's how we can reference the value that's in there. And that's generally how you're going to be using it. Again, it's a lookup table like a dictionary. I want to know what the name is. I want to know what the age is. And so that is how you would use a dictionary. Changing an item in a dictionary, again, even though they are unordered, they are mutable. So we can change the values in here. So very similarly, the same way that before we could use the index to change things, and now we can't use the index anymore. We have to use the key. We can go ahead and use the key here. So we could say, if we want to change our name, we can call the name of our dictionary. And I forgot to change these. This is a bad example. Let's change these now so that they make sense when you're looking at them on your own. Just so that makes sense. You may be confused if you go through that. And this is lowercase. All right. Present. Let's go ahead and change an item. Let's change my name. So let's do X. Let's see, name. Let's change it to, I changed it to Jimmy on there. Let's change it to Jimmy again, to Jimmy. And now let's go ahead and let's print X. Let's go ahead and print our dictionary. And now the key, the value of the key has changed. So yeah, I've now changed my name to Jimmy. I can do the same thing with my age. Let's change my age. Maybe Jimmy is actually, let's check something out. Maybe we made a mistake and Jimmy put in for his age. Maybe he also put in Jimmy. This will work. I knew this would work, but for something like Go, for those statically typed languages, if you were to set a value like this, we wouldn't be able to change the type. But let's change our age to something a little bit better suited. Maybe Jimmy is 47. And let's print it out again. So now we still have the same dictionary. It's the exact same dictionary, but it has different values for these keys that are inside of it. So what have we taken away so far? We learned about what dictionaries are, these KeyValue stores. They are unordered KeyValue stores. So you can't use, they're not indexable. You can't use the index to refer to the location, but an empty dictionary is curly braces to get dictionaries with values. The same way that we would do lists is curly braces with the actual items in between, but those items are now KeyValue stores. So a key with a value separated by a colon, and then a comma separating each of the items in the dictionary. Then we learned we could reference it using the key, and that we could change an item again using the key and assigning a value to basically that key. Now, how do we add items to the dictionary? So we don't need to use any append methods here. We basically just specify a new key. So we have name, we have age, and we're going to add in weight here. So let's say we wanted a new key here. We can do this is just like setting a variable. We're going to say the key of weight. So we're going to reference X, which is our dictionary, with the key of weight equals 200 pounds. We're going to hit enter, and we don't get an error here, and we'll print this out. Now weight is now put in here. It's now put in here. So that's how you add it. You don't need to append. You just need to set it like a variable. We could do this with any number that we would like. But what would happen if you tried to reference maybe a key that wasn't there? So if I tried to print, maybe we're gonna look for height in there. Maybe we thought height was going to be in this list because it's logical that if name, age, and weight was in here, the height would be in here. And we tried to print that out. It would basically run through, and it would look for the key, and it would say, well, it wouldn't run through. It would look for the key, and it would say, hey, height's not here. I don't know what you're talking about. But you can just as easily add height the same way that we added weight, and just go ahead and type in a new thing here, and let's set that equal to he's 47 years old and he's 4'7" tall. I can't do that. That makes sense. That was dumb. I was using actual, it wouldn't let me do it because I was opening up a string and not closing it. 4 foot doesn't make it a string. 4'7". Whoops, can't do that either. Single quote. Wait, single quote. This is also not gonna work because, let's see, open, close. But then we have the one here. So this is, I actually don't, what's the best way to do this? It's dumb, we shouldn't do this. Oh, string literal. Never mind. Okay. Look, this person is 4'7". I'll show you guys how to fix that in a second. 4'7". I want to move on. I just want to mess around with that. 4'7", and we print it out. We know his height is 4'7". Yeah, there we go. Just escape characters. I thought I could Do you have to escape it? I think you can do it with quotes. Maybe not. Start the string with R. Yeasty goodness. What's the R? That's interesting. I don't think I know about this R thing. Is this a Python 3 thing? What is triple quotes? Triple quotes. I think that's what I was looking for. Raw strings. Yeah. R is for raw strings. Oh, yes. Man, yes, absolutely. Absolutely. It's funny when you're reading things in the chat without like, I don't know, because my mind, like when your mind's on one thing, it's very interesting. Yes, R, raw strings, absolutely. Triple quotes will give me the same thing for that. Got it. Cool. All good. But we've added a new key called height, and we set it to 4'7" Whatever. That guy's really short, and if he's 4'7" and he's 200 pounds, that sounds heavy for a 4'7" person, but maybe not. I don't know. Seems really weird. So maybe he's a hefty fellow and he's getting up there in age, so he should probably work on that. But that's a dictionary. KeyValue Stores for that. So now we know how to add something. How do we delete something? And we use the delete keyword here to delete items from the dictionary. And so the same way that you can reference anything, you just delete the thing that you want referenced. So, yeah, Jimmy does need to put the fork down. So if I want to delete something, I want to delete his height because he doesn't want anyone to know his height. I will say X, and then I will give it the key that I want it to delete. And it will go ahead and it will delete that key and that value. I'll print it out again, and now you can see height is no longer in this. So that delete keyword is how you would do it. Delete keyword works for a few other things, as we're going to go over tonight as well. But again, think about how you could use a dictionary. Maybe you're just doing a simple, I don't know, sign up app for something, and you need to get everyone's, name and address or something like that. For something, you could use a dictionary, and again, you could grab user input, and as they input things, you could set those values equal to the keys in this dictionary that you are using. So just trying to give you some random real world examples that make this stuff make sense. We'll be touching all of this stuff. Let's see, when will we be touching all this stuff? We'll be using it kind of in real world settings. I think it's pretty soon. So we're doing this tonight. This is where coding gets fun right here. So like all the stuff you're learning now are kind of the tools in the toolbox. This is where like decisions happen. This is where you start like making decisions like here and here. Oh yeah. So just, you've only got two more, and you are into then we're going to be solving all types of problems. And from here on out, we're going to be solving problems. Excellent. We'll get through it's not the boring stuff, but it is the boring stuff in comparison to the cool stuff that we can do with this code. All right, present. Those are dictionaries. Let's take a break. I think I'm done with I'm on my last sip of lemon. I'll give it a little bit, and then I'll move on to the lime Lacroix so that I don't get that weird fake Sprite taste in the middle. I like the very distinct flavors of both of them. All right. Does anyone have any questions? If you update to Python 3.8, you can use the walrus operator. I love the walrus operator because I like Golang, and it just comes naturally to me there. Haven't used it in Python at all. Actually, what version of Python do I have? Maybe I will upgrade to 3.8. Can I type in version here? Does that work? Nope. D 3. Whoops, this is not Go. I need a dash dash. — 3.75. I'll update so that we can do that. Yes, inline creation, assignment of variables. That, I know that when I was coding, that would mean nothing to me when I was learning how to code. So if you read that it allows inline creation and assignment of variables, you might be like, man, that makes zero sense to me, and that is okay. It will make more sense to you. I like that. I do like this. Let me copy that and see if this pastes fine. Oh, I don't have, never mind, that was dumb. I can't even use it because I don't have 3.8 yet. I still have 3.75, so it has no idea what this walrus operator is, but it allows you to do, set the value of in here to the length of my string. So basically this thing is kind of checking if your string is like empty or not. A very quick way to do that. It's super weird. Those will make, this type of thing is going to make more sense once we get into algorithms. Like, yeah, this is the first time I think I started coding and I like saw a paradigm where, you know, to find out, like to determine if something existed or not, you checked if it had a length. That was a very interesting concept to me the first time, like, because obviously something that doesn't exist is going to have a length of 0. So if it has a length that exists, then it is not empty, and you can make some decisions based off of that. But very interesting. No video. I don't know what that means. Walrus operator is really just syntactic sugar. Yes, it is syntactic sugar. So it makes stuff that would take more steps really nice and really easy for you to use. All right, now we're gonna get into, oh, so I said try it yourself. I forgot this was in here. So we'll take some time. I'll leave this slide up. If you're following along and you're typing some stuff in either a file or either your own interpreter, try this out. So use a dictionary here. Make a dictionary called address. And we'll go through and we'll try to do this afterward. We'll do this afterwards together. We'll run through, but make a dictionary called address. And give it the following keys. So this is also a good exercise in starting to read through problems. This is like a good actually introduction to some problem solving. This is not a problem, but just you're introduced to the words that you're not used to probably. So make a dictionary called address. That's the first. This is the first actionable item right here. You can make a dictionary called address, and you want that dictionary to have the following keys. You can choose whatever values you'd like. So dictionary, KeyValue Store. So you need to have these keys, but you can have whatever value. So it needs to have a house number, street number, city, state. So do that first. And then I want you to say, whoops, we forgot something. Let's try adding a new entry to our dictionary for zip code. So take a minute or two, or three, and see if you can figure out how to do just that little bit. And then we'll hop on. So what do we have? What do we have left? Let me make sure we have time for, we have tuples and we have sets. Perfect. This is perfect. I'll leave this back on. Take some time. Take your time with this. We'll run through in a second. Make sure you can set up a dictionary. Dictionaries were, to me, I got lists right off bat. And I think when I was learning, I was like, oh, it's perfect. Like, a list that makes perfect sense. It's just like a shopping list. Like, it's a collection of items. Pretty easy to, like, I get that. And then we got to dictionaries, and I think because it was never explained to me originally as a key value store, because it was never explained to me like that, I think up front, it was super weird. I forgot how it was explained. It was explained in a really academic way, and I didn't really understand it. I don't know why I didn't understand it, and I don't know why I never made the connection to an actual dictionary. But it took me a little while to get it, and then I really struggled like with the syntax and stuff, which is fine, completely fine. During this part, I don't need you to know how to do it off the top of the dome. You can feel free to Google, how do I create a dictionary in Python? Very simple, like that. Like, it is okay to do all of these things. Like, you don't need to memorize it. You can simply Google, how do I create a dictionary in Python, and start with that. But again, because you now know that there's this thing called a dictionary. You now know that it's some type of data type that I can now use to structure my data. And it's a key and a value store. When you kind of Google how to like mess with a dictionary, you'll start to see examples and you're like, oh, like now I remember, like, oh, I know I'm supposed to be thinking about curly braces, and I'll put the curly braces in there, and I know I need to put the key, and I know that the thing that separates the key from the value is a colon. I see that colon there. Perfect. I got that thing there. And then I know in between each of these is a comma and things like that. Like it'll all come together once you have once you know that this thing exists and kind of have an understanding of what it is. You can find the syntax and you can put it together. Whenever you forget how to do it, you can put it back together yourself. Cool the ego, but te ego. I like that. Or te ego. If it's te ego, I feel like you're trolling me because you like waffles more than pancakes. I don't know if you were here from the beginning, but pancakes are superior. Oh no, we've got another waffles lover. Waffles are great, not like pancakes. But I'll let that slide because Eggos are good. Eggos are very good. We all grew up on Eggos. Well, at least I grew up on Eggos. That's why I'm trying to lose weight now, because I grew up on Eggos. Paste the code that's giving you the error. Forgive the naming, but delete our dictionary Catman. It's simply, let's see. Waffles are bad, pancakes. Let's see. All right. So I do agree that Eggos are not great now. So the only way that they're good, I haven't had Eggos in literal years, but the last time I had them, I remember I buttered them, and I actually cooked them in the oven, which was super weird. It felt super fancy. It felt like a gourmet chef. I saw someone else do this, but I cooked them in the oven instead of in the toaster. Buttered both sides, frozen, and stuck them in the oven. Phenomenal. It was phenomenal. It was exquisite, and I did it a lot. I did it a whole lot. Sorry, my name always makes. I'm sorry. Yes, it's a big thing, man. I told you there's a reason why I put it in my intro slides, because it is a thing for sure. Caller next to me said, "How dare you, computer person, think waffles are not as good as pancakes?" Well, I don't know how to argue with an 8-year-old, but I do like waffles. I do like waffles, and maybe the issue is that we all have not had the same waffles and pancakes. Maybe there needs to be a national day where everyone gets to experience the exact same waffles and the exact same pancakes and can do comparisons. Maybe we all feel the exact same way, but some of us have had better waffles than others. Some of us have had better pancakes than others. I don't know. If you're arguing with an 8-year-old, you already lost. That is fair, just like when I did actually lose when I falsely stated that there were more IHOPs than Waffle Houses, but there are far more Waffle Houses than IHOPs. And if I'm wrong, I will admit I'm wrong. I think that you guys need to know that, need to respect that I will call myself out. I think I need that humility, and for you to trust me to teach you any of this stuff, you need to know that I'm willing to admit when I'm wrong. And I was wrong that time, but that was a fact. These are opinions, except my opinion is correct. So yes. All right, let's go ahead to make sure we can get out of here by 10. Let's go ahead and let's set this up. So we want to make a dictionary called address with the following keys, and we can choose whatever value we'd like. So let's go ahead and Python 3, and let's make a dictionary called address. So easy, address equals. So we're gonna set a variable, set a variable, and we know to make a dictionary, we need to go ahead and do this. So I'm gonna leave it right here. I'm not gonna submit it because I don't want to add a bunch of stuff to it. I want to see if I can set it all up from the beginning, but you could have started with just this and you would have been right on track. So let's go back up and see what we need to put in here. First thing we need to put in here is house number, the key house number, and we can give it whatever value we'd like. So let's go ahead and try that out. So I'm going to add in the key, house number. Sorry, you can hear the police station right outside. House number, that's the key. I'm gonna give it the value of 1234. So the house number is 1234. 1234 sounds better than 1234 for a house number. And I know that I need more keys. And so what do I need to do to separate this key from the next one? I need to throw in a little comma here. So a comma's in there, separated. So let's go see what else we need. We need a key called street name. So let's add another key. Same way we added the first one, street underscore name. And we know that's the key. So let's separate it from the value with a colon. And let's give it a value of Hyatt Street. I don't know where that came from, but Hyatt Street. Cool. 1234 is the house number. The street name is Hyatt Street. And I know that there's how many more? There are two more things that I need to have on here. So I know I need another key and value. So let's hit a comma to separate this from the next one. And what was the next one? The next one was city. So another key called city, and separate that from the value. And the city is going to be, I'm in Baltimore. So city is going to be Baltimore, but let's make that a string. Because without a string, if I don't put quotes around these characters, it's going to try to reference a variable which does not exist. And I know I need one more, which I believe was state. And the state is equal to, I said the state. I don't even know why I went up to the reference. The state is Maryland. It needs to be Maryland because we're in Baltimore, and it would be weird if it was Baltimore, Virginia. All right, so I think we have our whole thing here, and we can go ahead and press enter, and we got no error. So it looks like we did that correctly. So take a look at that for a second. Let's make sure it's a dictionary. How do we make sure it's a dictionary? Let's go ahead and check the type. And so we check the type of address, and we hit enter, and we get class dict, which is dictionary. And what else can we do? And let's go ahead and print it out. Let's make sure that it got the right information that we expected it to get. So print, and it looks like it has all of our information in this dictionary. So we could do, if we just wanted the house number, we could do print house number. That's how we reference just the house number. And we get 1, 2, 3, 4, perfect. We can do that with any of these options. Now, what was the little bonus thing on here? Whoops, we forgot to add something to the address. Try adding a new entry to your dictionary for zip code. How do we add a new item? Let's take a look back up one slide. And to add an item, we can just specify a new key and what it's equal to, and we'll get a new item. So we need zip code. So we need address. And then in here, we're gonna put zip code. What do we call zip underscore code? Whoops, let's see, yeah, zip underscore code. And whoops, that was dumb. So that's not in there. We'll set it to a value. Zip code here is 21202 or no, 21208. And something like that. I don't know what the zip code here is. And we do that. It does not give us an error. Let's take a look at our address. And now we can see a new key that's in here. So there's a comma here separating it from the last item. Zip code is the key, a colon here to separate the key from the value, and the value is 21208. And now we've successfully created our own dictionary. So hopefully you can mess around with that. Play around with dictionaries. Dictionaries are great. Dictionaries are also gonna be great when we dive deeper into object-oriented programming and all that stuff. And we'll be learning a lot of how to actually use this stuff. But again, the tools, I want you to practice the tools now. Get the tools under your belt so that you're not overwhelmed once we get to the logic pieces. Because the logic stuff can be overwhelming to learn in the beginning. This stuff, I think if you just take your time and go over it, I think you'll grasp these concepts. But the logic stuff might take you some time to get through. All right, we just got past dictionaries. Let's hop into tuples. Well, actually, let's take a break. Let your brain cool down a bit. Talk about something else besides Python for a bit. There is a Texas, Maryland, that's true. And a Brooklyn, Maryland. There's a Brooklyn, Maryland. There's also a there's a bunch of other weird like states, towns in Maryland for sure. Delete command is something unique. Yes, in the very most recent version of Python, that is also true. Oh, maybe it's not. I thought delete was relatively new as well. Works in my interpreter using Python 3.8.1. With the ID using, but I thought the delete keyword was new, but maybe it's not. How do you upgrade Python on Pop! OS? Great question. Yes. So if you can't get it by default, with like your package manager. So if I did apt upgrade Python 3, if there's no upgrade for it, because there might be, I have no idea. Whoa, I've got some new stuff here, but I think it's still Python 3.75. Let's see what this spits out. I've been having some trouble for larger. I'm not doing this right now. This is going really slow. 6%. Ooh, let's see. So, little note about my setup here. Whenever I actually have a server that's running, there's the Synergy server. I talked about it before, that switches my mouse from my Windows computer to my Linux computer that's sitting below my Windows screen. And it just kind of, if I go off of one screen and go to the other, it kind of moves back and forth. If I ever do anything network intensive, that like dies, and I can't like, I have to like use the laptop mouse pad and stuff to be able to do anything. So if you ever see me fumbling whenever I'm downloading something like this, it's because it destroyed my connection with my little Synergy server here. But yeah, you would have to compile it from source. Or there may be a .deb that you could grab, which you probably have to compile it from source. Caveat: any reason to upgrade Python other than 2 to 3? Is that a question? Or it's a question. Any reason to upgrade Python? Sometimes there's security updates. Generally, it's functionality updates. So if there are things that you need from the newer versions, it's pretty smart to do so. Just because it can get pretty tough to upgrade if you've developed on one version, and if you have a huge code base, it can get kind of tough sometimes. So I generally like to stay as up to date as my code base will allow for, personally. If I'm using something like right now for this course, I don't think there's any reason I can think of offhand for upgrading. But yeah, you don't want to. I was actually looking at the map earlier today and just saw the Waverly is better. Waverly, that sounds phenomenal. And all towns should be made like that, so that you can move out of one. So everyone in Waverly can, even if they're doing amazing, they can do better, and then they can move to better Waverly, and they can feel like they're better than the people in Waverly. Because that's what I would do if I lived in Waverly, and I might just move to better Waverly to, I don't know, just make myself feel better about myself, or at least about everyone in Waverly. That's very interesting. I always wonder how like things got named on the map. Like, I don't know, there's like upper, I was raised in Largo, but then they rezoned it, so now it's Upper Marlboro, but there's no Marlboro or like Lower Marlboro. It's like super weird, super duper odd, really weird, but cool. Let's move on to, I think they have a 3.8 dev package, but not 3.81. Okay. Hey, POE, what's this? Bruin Bob, welcome. You broke your lurk. I don't know what lurking is, but you broke it. So I think that's a good thing. You were lurking in the background. Now you're in the spotlight. You were in the shadows. Now you're in the spotlight. Good evening. How you doing? All right, we're on the tuples. All we have left is tuples and sets. And these should be quick. Because they're very similar. Like the things that we've touched are similar. We're going to talk about arrays as well, but that's going to be pretty short. But yeah, tuples. Let's talk about or tuples. I think we determined that it's tuples when I went to Google, and Google told me that it was tuples instead of tuples. So tuples. What are tuples? They are lists that you cannot change. So a tuple is a sequence of immutable Python objects. Don't worry about what Python objects are quite yet. I was going to go into that real early, but not important quite yet. Don't worry about that yet. But they are immutable. We talked about the words mutable versus immutable. So immutable, yes, immutable means that they cannot change. Python objects. Tuples are sequences just like lists. So conceptually, get that into your mind as it being a list. Conceptually, it's the same as a list. The differences between tuples and lists are that tuples cannot be changed, unlike lists, and tuples use parentheses, whereas lists use square brackets. So lists are the first things that we learn. We learned about lists first. The only difference between a list and a tuple, or a tuple is that lists are mutable, they're changeable. Tuples are immutable, they cannot be changed. And we know that lists, you define them with two square brackets. And now tuples, you're gonna be using parentheses instead. Yeah, so they're pretty easy to quickly identify which one is which. And again, you can also use the type function to figure out the differences there. So just like everything else that we've done, we have the same list of things we can use to work with a tuple. So how do you define an empty tuple? We can say our tuple equals parentheses. Now, don't do this. Why would I tell you not to do this? I'm gonna do it real quick, but why would I tell you not to do it? So let's full screen this. Wow. I exit out of there. Also, if you see me fumbling around, struggling to like click in the right place, or if you see me mess up typing a bunch of stuff and I'm typing the right thing and I keep backspacing, it's because there is a bit of a delay in the server that's like the Synergy server. So there's a bit of a delay. So like I think sometimes I'm moving a little too fast or trying to move faster than the output that I'm getting. All right, so a tuple. Let's define an empty tuple. I'm gonna say our tup equals open parentheses, closed parentheses. And let's do the same thing we've been doing. And let's check the type. Man, I cannot, of out tuple. Let's check the type of out tuple. And it lets us know that it's a tuple. So you can check the type of a tuple. Remember, parentheses on assignment is when you should be thinking about tuples. Parentheses elsewhere, you should be thinking functions, but that is a tuple. All right, let's go to the next thing so that we can start to figure out why I said do not do this. We're gonna do this, we're gonna give it a different name. Actually, no. Let's go ahead and do exactly this. So we've got to find a list. We can, let's go ahead and copy. I forgot you can't click into this until you're out of it. Let's copy this so I don't have to type it. Let's take the same stuff here. Copy, let's go down. Let's go ahead and let's try to set our tuple equal to this. So close. All right. Oh, well, that's a different error. And that's because when you copy over from, what's that thing called? Google Docs, all the stupid quotes get all weird. And this is annoying. This is why Vim is great. And I wish, oh, I broke everything. Can I just undo? No. All right, we'll just make our own. So all out tuple equals Aaron, comma, 3.14, comma, egg. This is all we need to do. And close it. All right, so let's go ahead and print out. I actually don't know why this works. I actually don't know why. That worked. Oh, yes, I do. I do know why that worked. Ignore me. All right, I know that worked. So this is how you print. This is how you create a tuple with items in it, the same way that you would do a list, same way that you would do a dictionary. We've learned this. This concept is not new to us. If we want to create an empty one, we can, with nothing in it, or we can assign values to it straight from the beginning. Now, referencing an item in a tuple. Let's change this. Let's change all of these. I could just do a find and replace, but I'll just do it because I'm here. All right. Referencing an item, just like a list, because remember, a tuple is essentially the same thing as a list. Not really different. Again, what are the two things that are different about them? One, tuples are immutable, so they can't be changed, whereas lists can be changed, and parentheses instead of square brackets. So you can reference them the same way. So this is an ordered list of things. I can say, let's set this back to this. And if I want to reference a pi in the middle, I can say out tuple, or our tuple, out tuple, 1. So this is the 0 item. This is the 1 item. And this will give me 3.1.4. So same thing that you can do with lists. So we're kind of getting a 2 for 1 here from the things that we learned from a list. Getting a 2 for 1. All right. Now changing items in tuples or tuples. I'm never going to get that. I'm never going to be consistent with that. Nope. Can't do it. Remember, we go back one slide. They are a sequence, just like lists, but they are immutable. They're immutable. So they cannot be changed. So that is why I said you generally don't want to create an empty tuple, because it can't be changed. So when you saw me redeclare it, and that works because you're not changing the tuple. You are now assigning this variable to a completely new thing, but you cannot change the tuple. So I cannot say tuple, the tuple gang. Yeah, tuple gang. So I'm definitely a part of the tuple gang, Steez. For sure, a part of the tuple gang, but we looked it up last time. And again, when I'm wrong, I will admit I'm wrong. And Google and YouTube's, they pronounce it tuple. So I'm gonna go ahead and I'm gonna do my best to be correct, because I want you walking into interviews saying the right stuff. So let's say I try to change something. So let's say I now wanted to change 3.14 to pi like we did before. And I said out tuple equals pi. And we get, whoops, type error, tuple object does not support item assignment. Can't assign and you can't assign a value to an item in a tuple because it is immutable. Once it's set, it is set. Can't be changed. Or the tuple can be changed. It can be added to, the items can't be changed, but you can delete, you can delete the whole thing. You can't delete individual items. You delete the whole thing, but adding items, nope. So a dot append does not work. You can't, there's no way to add a new thing in there. You can't do, a new index or something like that. Nope. Nah, doesn't work. Deleting item from tuples, nope. Got to throw the whole thing away. Delete the whole tuple, and you can use that delete keyword again, just like before. And so if I wanted to delete our list, I would do delete out tuple. And that will go ahead and make sure our tuple is no longer a thing. Our links allowed. The link is how to pronounce tuple from the ex-BDFL himself. Yeah, I think you should be able to post a link. Pretty sure you can post a link. See. Tuple. Oh!
Tuple.
Wait, can you guys hear that? Can you guys hear when? I think you should be able to hear when.
Tuple.
Maybe not. I don't know if I have like all my sound. It does say tuple.
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 All right, hold on. You know what we're gonna do? We are gonna actually. Alt tab. Let's bring this back up. We're gonna stop the music for a second. And
tuple,
got tuple for the UK people.
Tuple.
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 tuple,
All right. So if I go to Google, I type in tuple, pronunciation. It's literally the second thing that comes up, but that's probably because I typed it in before. We get
tuple,
a tuple. And here, I'm opening up some YouTube pages really quick.
Tuple.
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 Your link is the correct way, though. And what's funny is, in school, I'm pretty sure I was taught tuple.
tuples,
Tuples. All right, I'm back. I'm back on the tuple gangs. It's tuple. I'm going with tuple because my brain says tuple, and I was trying to correct it. I'm saying tuple because your link is correct, and you sound very confident in that. Was that Stupac? You sound very confident, and I want to thank you for making me more comfortable. Because I really hated saying tuple. It was really bothering me. And that's why I just kept saying tuple, because I like saying tuple. Hey, Dapper, welcome to the channel. You didn't click my link. I definitely did. Google, used to Don't Be Evil. I clicked it. Cool. All right. Oh, that was your link. Hold on. Are there two links here? Twitter. I pronounce tuple. And tubpool. Oh, Monday, Wednesday, Friday. What's today? Monday. Today is Sunday. All right, guys. I have to say, on Sunday, I don't talk about them. All right. Now I did click it. Yes. So apparently it's pronounced tuple on Monday, Wednesdays, and Fridays. Oh, no, today's Monday. So it's tuple. It's definitely tuple today. I'm tripping. I thought today was Sunday. It's definitely tuple today. On Tuesdays, Thursdays, and Saturdays, it's tuple. And Sundays, we don't talk about it. So I like that. I'm saving this tweet. I'm liking it. It's from 2011. Like, save, because I think these are words to live by. And I think it's easier for me to go by this logic than it is to figure out one or the other. So I love that. I definitely love that. I'm in the tuple squad. It's tuple today. So if you want to follow, if you're a rule follower, today it's tuple. Mondays and Wednesdays, every day that we have class is going to be tuple. So we don't have to worry about it ever. Never have to worry about it. All right. Pretty sure the creator of Python did not create the concept of tuple. I agree, but he said it's tuple on Wednesdays in particular. So cool. All right, let's put the music back on now that we've kind of gotten that out of the way. Let's hit a little play here. Let's get that back in there. All right. Tuples, you can delete the tuple. Remember, again, just recap. If you want to know how to use a tuple, simply look at how you use a list. What's the difference between a list and a tuple? Again, lists are mutable. They can be changed, and they use square brackets to define them. And then tuples can't be changed. So once you kind of set up a tuple, can't be changed. You just got to delete it or create something else. Can't add to it. Can't append anything to it. Can't change any of the items. It is immutable, and that's the only difference between a list and a tuple, and that it has parentheses. So very, very, very simple. Yeah, very simple. It's nice. So you kind of give 2 for 1 there. You might be confused right now about why you would want an unchangeable list. And there are a lot of reasons why you would want an unchangeable list. And you're going to start to, again, see these things. You're going to start to see why these data structures are important when we start doing some of these algorithmic problems and just solving some problems. Cool. Now we're on to the last one, but let's talk about arrays really, really quickly. Arrays in Python, and if anyone has something to add to this, feel free to add to this. But arrays in Python, they are very similar to things like lists. But in Python, you have to actively make basically a list, an array. And you have to, you can't use it right out of the box. I'm pretty sure you have to import an array. So if you look at it in W3 schools, it actually just runs through it's just showing you lists here. So this is a list and not an array, because they are very similar. They're similar. They're not the same. I'm actually interested in why they put this here and if this is the exact same thing as lists. Interesting. Okay, but you have to explicitly make an array, define an array, which is a little bit annoying. But the difference between a list and an array are the functions that you can apply to them. So an array is actually pretty cool because you can do things like divide divide an array. Like if you have some numbers in there, you can divide the whole thing and it will like divide each of the items. And maybe I can show you a way to do that. But mostly arrays have been like, now people use the arrays from, NumPy instead, which actually have a whole different suite of things. So I don't know, arrays are a very weird, they're just a weird thing. So you have to import it first, import array as array, and then you have to explicitly define it here, which is fine. But yeah, there are different sets of functions that you can perform against lists that you can against arrays. I think that's something that you should dive into on your own. I don't think it's crazy important right now. It is something to dig into. I do think this is a common, like if you're trying to be a Python developer, I think this is a relatively common interview question. I've heard this question come up a fair amount. But I don't think it's worth your time. I don't think it's worth the cognitive load of actively trying to understand the difference between this and a list right now. I think these basic data structures will help us out for now. Yep, not important for beginners at all, just teach lists. I agree. But I did want to let you know that when people are talking about arrays, because they're called arrays basically in every other language, if it, like, this is the thing that they're generally referencing, this is what you can use to, for the most part, get the same thing. You can do that with a list, with list comprehension. Yeah, yes, you can absolutely perform some of the functions and things you can do from an array. You absolutely can perform to lists with something called list comprehensions. List comprehensions are they're these kind of methods for applying actions to items in a list. And pretty interesting. We'll definitely get into some list comprehensions. We'll need them to solve a bunch of problems. Yes, for sure. Get a pie hole. Actually, is that a package? I don't know what you're talking about. Been no Python personal projects for years and never used arrays. I agree. I've had to use an array a single time. I thought I had to use it, but I think I could have used a list comprehension that time, but I didn't know. I didn't know I could do that at the time. This is a long time ago, so I don't know. Oh, Raspberry Pi that blocks ads. That's nice. But I will say I'm not I stopped using ad blockers. Ads are annoying. But although it didn't appear to be so, when you guys saw those movies that were those movies that were on my computer, actually, no, it wasn't you, it was last night. So last night there are some, if I go into my movies folder, my documents folder, you'll see things like Joker and some other movies that kind of aren't out on DVD yet. I actually do pay for almost everything every amount of digital content that I consume. So like I actually turned off my ad blockers because I pay for YouTube Premium and stuff like that, just because like I'm like, all right, man, people are spending their time doing this stuff, so I do turn off ad blockers. But I definitely understand. I used to use it, but then I felt bad, and I'm really just trying to give back from. I mean, I'm gonna be honest. If anyone from the government's listening, I think I spent from the age of 13 to the age of 21 pirating as much as I could. But hopefully I'm giving back. I buy a lot of digital content. I go to the movies very often, buy a lot of video games. So hopefully my contribution back to society has been taken care of, for sure. All right, let's see. Touring movies is going to increase because 100%. You are You're absolutely right. The gatekeeping, it's only going to go up for sure. And I think there are interesting ways to solve some of these issues, but you know, everyone wants to keep. Everyone wants to have their way to make massive amounts of money. When I think there are other ways for them to make massive amount of money off their content, but it's all good. It is all good. People will find a way. The internet has kind of opened up too many things, like too many options. So, cool. Sponsor block for YouTube is pretty great. All right, last thing. Let's hop into the last thing because we have 6 minutes. Pretty simple. We talked about a bunch of things, and let's hop into sets. Rep your set, Python set. That is, I'm not encouraging any type of gang affiliation. It's just a little jokey joke. Don't little play on words. I don't want anybody coming back. Oh no, you talk about repping your set. Now my kid came home and start talking about where he's from. No, We're talking about sets. Sets in Python. A set is simply a collection which is unordered and unindexed. And that's why the picture on the left, which is a bunch of chaos, is there. It's unordered, so it's unordered and unindexed. Yeah, so this is kind of like your dictionary is. Not, you know, the stuff's just kind of in there. In Python, sets are written with curly brackets. Think a dictionary, but without the key. So the same way curly braces are dictionaries, they're also sets. But the difference now is it knows it's a dictionary. It knows it's a dictionary when it has keys and values, and it knows it's a set when it doesn't. But you can also typecast. Like if you have an empty set, you can have an empty set. These are I don't think sets are immutable. I think they are mutable. So when you have an empty one, you can typecast it to set. And I put it right here. To define an empty set, you basically define an empty dictionary and you typecast it to a set. And we'll do that in a second. So again, these sets are basically just, it's a set of data, unordered, unindexed, just a bunch of data just thrown in there for you to use. So let's go ahead and create a set for ourselves really quick. And remember, we said it's basically a dictionary. So let's say X equals open close. And we do type X. Take a look at that. Oh, whoops, not typer X, just type X. And that's a dictionary. So if we want to set an empty set, we have to typecast it to a set. Essentiate an empty set. Oh, that's cool. I didn't know that. That makes sense. That actually makes perfect sense. Maybe I didn't know that. I literally never use sets ever. So class set. That makes perfect sense. That makes a lot of sense. I'm changing that right now in the slides. Get out of here. Let's see. That makes literal perfect sense. And what is this? Oh no, that makes sense. I don't know why that looks so wrong to me. Let's actually just delete everything in between. Delete key. All right, there we go. No, that's not what I wanted. I wanted our set equal set. Cool. All right, I'll make that lowercase in a second. Perfect. That's the only way I do it. Yep, makes sense. That makes perfect sense. I use set to remove duplicates. Oh yes, I lied to you. I've used set. I said I never use set. I never use sets. I used sets last week to remove duplicates. I think the problem is I've like moved away from all the big scripts where I would need to do something like that. Previously, I would just do them in Bash. We actually wrote some big scripts for our project last week. We've been fighting through them for a few weeks now, actually, and we had to remove some duplicates. And I did use set for that. That was interesting. That was very interesting. And now I'm determined to find some kind of problem or create a problem. Maybe I'll recreate something. Maybe I'll recreate some items from the script that we created here. But change all the data and change what the actual goal is. And maybe we can try to do something like that here. Makes sense. See, man, sometimes I read stuff like this and I really want to spend some time being I really love development. I actually like development a lot, even though, like I said, my day job is DevOps. And so I love infrastructure. I love cloud computing automation, but, I think it would be cool to spend some time as a strictly a dev. I would really want to be a Go dev, but like really anything. I think it would be fun to do, just because like I use whatever tool I need to use to solve a specific problem. But when you do that, you don't pick up, you don't pick up some of the things that you would if you were using this to actually build out an application and spend some real time with something. I don't know. It'll be pretty interesting. Yeah. Okay. All right. So I have a list of things that I need to do after almost every stream, and I'm still getting caught up on it. Nightbot was on there, and it was up on there pretty high, but I think I got on there and I didn't know how to like make it less restrictive. This is going to the top of my list, and I'm gonna make sure I make Nightbot because I don't really care what you guys put in the chat. To be honest, it is pretty darn strict. Essential DevOps episode 1 coding Python series. Oh yes, it's probably gone off of Twitch now. I rendered all of those videos out. They need to go up on YouTube. I forgot to upload them to YouTube last night when I left, because last night we actually streamed. I rendered them out yesterday. We streamed until midnight last night. Not unfortunately, but so I didn't have time to press the upload button. Before I leave here tonight, I'm pressing the upload button. So those will be available to you in the morning. Definitely by the morning for sure. So sorry about that. And then after they get uploaded this current time around, they will be getting uploaded 48 hours after they stream. I have to push it to 48 hours because of some Twitch policies, but they'll be up on YouTube 48 hours afterwards. So sorry, they're a little bit late getting up there. I'm invited to Google Ubar, something important. Yeah, Nightbot's a little strict for sure. All right. Working with a set. So sets, again, they're just this unordered set of data. So very similar to things that we've seen. We can set a set like this. We can add stuff in our set, just like a list. And so we can do X equals, and again, this is a set because now, it does not have keys and values. There's no colons here to separate keys and values. It just has some commas here and Aaron and 23 and pi. Cool. And so if we print X, this will print. And if we type X, it will let us know that it's a set. It lets us know that is a set because, again, it knows that because it knows it's a set as opposed to a dictionary because there are no keys in there. There's no colons in there for it to do. Let's see. Now you're reassigning X. I did not expect that. Yes. I'm sorry. You can always reassign values for variables. So I just use X again because it's easy to type. All right, and then what else? Was there any more caveats with this? So referencing items in the set. So remember, I posted that picture of sets being a little chaotic. You cannot reference an item in a set. You can work with these values. You can actually iterate over values in sets using for loops. Using for loops with the in keyword, but we aren't there yet, so I don't want to introduce that now because that is a much bigger topic. Changing an item in a list, double note, can't do it. Can't change an item in not a list. Oh man, I shouldn't. This is what happens when you copy and paste poorly. Set in a set in a set in a set. You cannot change the value of an item in a set because again, you can't reference them, so you can't change the value of any of the items in there. But you can't add items to the set. So you can't change items that are in the set because you can't reference them. But you can add items to the set with the .add method. So let's go ahead and add an item to our set. So we have this set here. We have X, the set X here. Let's go ahead and add something else to it. Let's go ahead and add. I actually think it's. Let me see what happens if we do something like this. Let's get kind of confusing here. I think address still exists. No, it doesn't. Okay, I forgot I got out of here. All right, so let's go ahead and do x.add. So we're gonna use the add things, the add method. And we're gonna go ahead and add in here, I don't know, the string table. I don't know why we would add that, but first thing I thought of, we're gonna add it. And then now if we print out X again, when we print it, we now have table, and it goes ahead and sticks it on there. Doesn't really matter where it goes because again, the order does not matter here at all. So don't sweat where you're seeing it. Table, and we can add another thing like chair. And we can print it out again. And now we have chair, and you can see chair just got stuck in here somewhere. And that is a set. So that's how we add things to a set. And then we can delete an item from a set. So we can remove things from a set. So we can use this remove keyword just like our list. And we can use the remove keyword. And we have to, again, they're unordered. So if we want to remove something, we cannot reference them by their placement or their index. So we have to reference them directly. So we can do x.remove and something like 3.14 because that is an option in our set. And now if we print this, 3.14 is no longer in here. So you actually are removing this item. So this may be something you care, like maybe if you're making a shopping list, maybe you prefer to use a set instead of a list. Maybe you want to use a set because you could just throw things in and pull them out by name. Maybe, who knows? That's your choice. You can solve that problem using either one, to be 100% honest with you. But they all have their things. Sets print out as floats, ints lower than uppercase. What does that mean? Sets print out as floats, ints lower than uppercase. Floats, ints. I don't know what that means at all. Like the order it prints out. Oh. I don't know. I have no idea, actually. No, I don't think so. I don't think there's I don't think there is a structure to how it prints out. I think it just kicks stuff out. Maybe I'm wrong. What happens if I add in like another, oops. Yeah, I don't think there's a method to how it prints. Maybe. I'm not sure. Intersection and union, great with sex. Yes, we're not going to go over those right now, but yes, they are. We will add it. We'll add in all the little like modifiers to these things and things that you can kind of be great with as we get into solving problems with them. Things that makes it a little bit easier to remember. Sets are mutable. Frozen sets are mutable. Absolutely. Okay, cool. All right, 10:08. We've gone through everything we need to go through tonight. So let's talk about what we went through tonight. And again, I know if you're someone who knows Python already, you're like, there's so much we're missing, and like there's so much we could be going over. Yes, but again, think about when you were first learning. This is a lot for a 2-hour session, and now people who are just learning can take some time and go over these things. So. One thing you'll start seeing, and I'm adding them to the slides now, is tangible takeaways. So I'm starting to add tangible takeaways to every session so that people can get to we're gonna go over them at the beginning, so that people can know what to expect to get out of this, and then at the end, they can have tangible things they can walk away with, hopefully walk away with, and they can dive deeper into if they don't fully get those tangible takeaways. But the tangible takeaways from this are that all data structures they're not some fancy crazy thing. All these data structures are structures. They're structures for organizing your data in a way that you can use them more effectively. So learning, like now that you've learned the different data structures that we have available to us, and you go back to this definition, now you can see that, again, dictionaries, these key value stores and lists, and being the ways you can reference those things, their collection of items and tuples, because it's Monday. Tuples, they're a little bit different than lists, but provide much of the same functionality, or all the same functionality. But you can see, you can take that information and look back at this definition and realize that all data structures are a way of organizing data so that you can use that data more effectively. And we're going to put that to work. Then you learn about lists. Lists is just a collection of data. Think square brackets for lists. Lists are mutable, so they change. You can change the things that are in them. They could take all different types of data types. We learn how to add things to them, remove things from them. We learn about tuples, which are just like lists, but they are immutable, so they cannot be changed. So they're just like lists, but they can't be changed. They can't be changed. And those are parentheses instead of square brackets. We learn about dictionaries, those key value pairs that you can use, and think curly brackets or curly braces to be able to, whenever you see those, you probably want to think dictionary with keys and values. Remember, the thing that separates a key from a value is the colon, and each of the items in there is separated by a comma. Then you learn about sets. So sets are like dictionaries. So also think curly braces, but there's no key and value. Sets are they're unordered, so it's a little bit of chaos. They're unordered and unindexed, so it's kind of just data just kind of in there, and you can't reference those things. Can't really reference those things, or as you know of now. And then what was the last thing we learned about sets? What about tuples? There's one more. What about sets? Dictionaries? Maybe not. I don't know. I thought there was another thing. But those are the main data structures that we need to know for now. So play with those things. Hop around. See if you can, create some things. Google around online. Maybe you can find some. Maybe now's actually a good time to start, just searching Python data structure problems or something like that. It's going to be way out of your league, but take a look at it and kind of see if you can identify some things in there. Just look at it and say, oh, all right, there's some square brackets here. I can see that this person is defining an empty list here. And I can see down here, I can see curly braces. Maybe that's a set, maybe that's a dictionary, and see if you can just start to identify some of these things in the code and just start to make those connections and those relationships. I think these data structures really help you do some cool things with code. Piling these data structures on top of the logic that we're going to learn in the next two classes. I already forgot. I just keep forgetting what we're gonna do next. Starting next time, Wednesday, we're gonna be learning about how to make decisions and logic and figuring all that stuff out. So that's gonna be great. Once we get into this section, we're gonna be able to combine those things, these data structures and these decision-making processes and these control flows, and we're gonna be able to do some really cool stuff. It's gonna be fun. It's gonna be really cool, and you're gonna start to see how we're kind of just building. We've been adding tools to our toolbox the whole time, and soon we're gonna start whipping out those tools so we can start building some stuff. We're gonna start out building, something real simple. We're gonna put together, a birdhouse. Then we're gonna put together a chair, and then we're gonna put together, a table, and then we're gonna build a wall of a house, and then we're gonna build the roof, and before we know it, we're gonna be building the whole house, and we're gonna know how to build the entire house, and it's gonna be super duper exciting. So that's data structures. Does anyone have any questions? I always love the Python course because we can get through the stuff in a reasonable amount of time. I like this pace. It doesn't take 4 hours for us to get through some crap. Anyone who's new, we will be back on Wednesday with a again, operators and expressions for Python. This is the Python. This is a 12-week Python bootcamp. We are on week 3. This is the start of week 3 of this. On Sundays and Tuesdays, we're actually running a 12-week DevOps bootcamp. So the curriculum is also on academy.mastermind.io. So if anyone's interested in the DevOps portion of it, we did a bunch of Linux stuff last night. We're going to be diving into more Linux stuff tomorrow. With more Linux stuff tomorrow, and then some lab stuff starting next week. But yes, welcome to Mastermind Academy for all the new people. I saw a fair amount of follows come through. I really appreciate you all being a part of this. But that's it for tonight. So usually we get to the end of this and we go ahead and we raid someone. It looks like the Prime again started streaming not too long ago. So we're gonna head over there. We're gonna check them out. We usually raid a channel. So I usually give people some time to ask questions. So I'll give you guys a minute or two to ask questions, and then we'll hop over and we'll raid the Prime again. And again, I'm always going to try to raid someone who I think can provide you some value. I think that the Prime again is his channel is, he does some cool stuff that might be a bit advanced, but again, I think being a part of that, I think his energy, I think the things that he's doing, like, I think it'll help you get less afraid. Anyone who's completely new, get less afraid of diving in with this stuff. And he uses Vim for everything, and he moves super fast, but he's not teaching you anything. He's having fun. He's having fun, and he is teaching you a bit, but he's not actively teaching you anything most of the time. But I'm always going to try to send you over to people like that, because I think there's a lot to learn by just immersing yourself in technology, immersing yourself in the concepts, and it's fun. You might, if you participate and you stick around and you participate in a lot of stuff, you pick it up so much faster. You really start to soak it up like a sponge. So that is it for tonight. Thank you for the great stream. I don't see any questions coming through. It doesn't look like we were in subs only. Thank you for the, who's that? P Dugs. Welcome. Thank you for the follow. I actually don't know what the Primeation's doing over here, but it looks like he's drawing something in paint. But we're going to go ahead and we're going to raid his channel. So let's go ahead and get ready to raid. Let's see. I really need to just save this. We don't always go to him, but he is someone good to go to. Pry me again. All right. It's going to go ahead and raid in, I don't think this is right. Pry me. Oh, there we go. Cancel. We were about to go to the wrong place. And that person must be streaming because I did not add D to the front. I spelled it right. It is the. All right, we're heading over now. So the infamous countdown. 7, 6, 5, 4, 3, 2, 1. Everybody have a good night. If you were off today, have a great start of your week next week. Go over and tell the Prime Vegan I said hello.